Hello everyone, my name is Sania Mamti. Our topic is slope overload error in delta modulation and its solution using adaptive delta modulation, also known as ADM. This concept is very useful for the digital communication system. First, we need to understand what is delta modulation. Delta modulation is a simple method of analog to digital conversion. Instead of sending the entire value of the signal, it sends only one bit per sample. That bit indicates whether the signal is increasing or decreasing. If the signal goes up, we send 1. If the signal goes down, we send 0. Delta modulation compares current signal value, previous approximated value. This makes delta modulation simple, bandwidth efficient, but it also has limitations, especially when the signal changes rapidly. As you can see in this diagram, input signal is overlapped. It is compared with previous output. Difference is sent to a 1-bit quantizer. Output bit tells whether the signal is increases or decreases. Adder plus delay reconstructs the signal for next comparison. The diagram's result is only 1 bit per sample is transmitted, but distortion can occur if step size is fixed. Now let us understand slope overload error. Slope overload error occurs when the input signal changes faster than the modulator can track. In delta modulation, the step size is fixed if the signal slope is too steep. The modulator cannot follow it. As a result, the reconstructed signal lags behind. The distortion is called slope overload error. Why it happens? High frequency signal, rapid changes in amplitude, small fixed step size. The error mainly appears when the step size is too small for fast changing signals. Now, we need to understand granular noise. Apart from slope overload, delta modulation also suffers from granular noise. Granular noise occurs when signal changes slowly, step size is too small, so we have a trade-off problems. Small step size is slope overload. Large step size is granular noise. So we need to solve this problem use adaptive delta modulation. Now we will need to learn adaptive delta modulation. Adaptive delta modulation is an improved version of delta modulation. The key idea is instead of using fixed step size, ADM uses a variable step size. How ADM works when the signal slope is steep, step size is increasing. When the signal slope is gentle, the step size decreases. The adaptation allows better tracking of fast signals, reduce slope overload error, and reduce granular noise. ADM dynamically adjusts the step size to match the slope of the input signal, so ADM provides better signal approximation, improved signal quality, less distortion. As you can see in the block diagram, input signal is compared with the previous output. The difference is converted into 1 bit, means up or down. Step size is adjusted automatically, increases for fast signal changes, second, decreases for slow changes. The feedback with the delay reconstructed the signal. The result is better tracking of signal and less distortion with normal data modulation. In a real-life example of that, human speech transmission. Imagine you are talking on a mobile phone. Your voice has slow changes means normal speech, fast changes means shouting or any emotions. If delta modulation is used, fixed step size cannot follow sudden loud sounds. This causes slope overload distortion. With adaptive delta modulation, step size increases when you speak loudly. Step size decreases during silence. Your voice sounds clear and natural. That's why ADM is preferred in speech and audio communication systems. In this video, we summarize slope overload error occurs due to fast-changing signals in delta modulation. It is caused by phase step size. Adaptive delta modulation solves this problem. ADM adjusts the step size dynamically. This improves signal quality and reduces distortion.